Module 15 Study Guide Part 1, all on geometric sequences and how to write an explicit equation given a geometric sequence. So for the first few problems you are asked to find the common ratio for each geometric sequence and then use that common ratio to find the next three terms. So please try to do all of these problems on your own first. That's the best way to study, and just use this as a way to check your work or maybe get help on one or two problems that you did not know how to do. So to find the common ratio, remember a geometric sequence has a common ratio, which is that common number that you're multiplying each time. Okay, so if we look at this one, it's pretty evident that the common ratio is going to be 3. But if you didn't know that, all you would need to do is take one of your terms and divide it by the previous term. Okay, and that would give you your common ratio. 15 divided by 15 divided by 5 is 3. You could have used any term, though. You could have used 135. 135 divided by 45 would also be 3. So that's just saying that this geometric sequence, we are multiplying by 3 every time. That's our common ratio. That's all that means. So I zoom in a little. That means we're multiplying by 3 every time. Multiplying by 3 every time. Okay. So we have our common ratio, which is r equals 3. That's our common ratio. But now we are asked to find the next 3 terms. So in order to find the next 3 terms, we would just have to multiply 135 by 3, and that would give you 405. Then you'd have to multiply that by 3, and that would give you 1,215. Then you multiply that by 3, and that would give you 3,645. And that's it. So for the next one, again, you just take this, divide it by your previous term. That'll give you your common ratio, which would be 5. Means we're multiplying by 5 every time. And 20 times 5 is in fact 100. 100 times 5 is in fact 500. Okay, so your common ratio is going to be 5. And then you could just use that to find the next 3 terms, which is the next part of the problem. And 500 times 5 is 2,500. 2,500 times 5 is 12,500. And last but not least, 12,500 times 5 is 62,500. So remember, when we're talking about common ratio, we're always talking about it in terms of multiplication, right? So you might say, well, this looks like we're dividing by 2 every time, right? And you'd be right, but you can't say your common ratio is 2 because it's not. Your common ratio, if you say your common ratio is 2, that means that you're saying you're multiplying by 2 every time, and 72 times 2 is not negative 36. 72 times negative 2 is not negative 36. So you'd have to write this as a fraction or a decimal. In class, we just did it as a fraction. So take negative 36 and divide it by 72, and you get negative 1/2, and that's our common ratio. We are multiplying by negative 1/2 every time, okay? And that's why your signs are changing. Anytime your signs keep changing from positive to negative, that means your common ratio is going to be a negative, okay? Now to find the next 3 terms, we would just multiply by negative 1/2. So negative 9 times negative 1/2 is 4.5. Okay, if we multiply that by negative 1/2, we'd get negative 2.25. And if we multiply that by negative 1/2, we'd get positive 1.125. Okay, so I think you're starting to get the hang of it, so you could figure out the common ratio the way we did the last 3 problems. This common ratio would be 3, and if you multiply to find the next 3 terms, if you multiply them by 3, you should get 810, 2,430, and 7,290 would be the next 3 terms of this geometric sequence. And then this one, 3 divided by 5 is 3/5. And your common ratio is 3/5. That means you're multiplying each term by 3/5 to find the new term. Now to find the next 3 terms, we would just multiply by 3/5. So your next term would be 648 thousandths. Okay, then we would have 0.3888. Then we'd have 0.23328 would be your next three terms. All right. Now we are asked to find the indicated term of each sequence by repeatedly multiplying the first term by the common ratio. It says use a calculator, okay? Because your numbers are going to get quite big, especially when you start trying to find the 8th, 9th, 10th, 11th term, as you noticed in class. So I know we've already discussed the formula that we use when we're trying to write an explicit equation given a geometric sequence, but that's not what these problems are telling you to do. They're just telling you to repeatedly multiply. All right. So here we have a sequence. We have the first term, which is 1, second term is 8, third term is 64. We're asked to find the fifth term. So before we could find the fifth term, we first need to figure out what's going on, what's our common ratio. And it looks like our common ratio is going to be, we're multiplying by 8, okay? Multiplying by 8 every time. So if we're multiplying by 8 every time, in order to get the fifth term, we first need to get the fourth term. So we need to multiply 64 times 8. And if you do that, you get 512. And that would be your fourth term. Once the fifth term, so you'd have to multiply that by 8 as well. And your fifth term would be 4,096. That's all you'd have to do with these type of problems. All right, let's take a look at this one. So if we look at this one, we take 15 and divide it by negative 50. That would simplify to 3/10. So our common ratio would be, actually negative 3/10, I'm sorry. Our common ratio would be negative 3/10. We're multiplying by negative 3/10 every time, okay? So if we're looking for the fifth term, we have the first term, the second term, and the third term. If we're looking for the fifth term, we would just have to use our calculators and multiply by negative 3/10 until you get the fifth term. So the fourth term, if we multiply 4.5, or negative 4.5 by negative 3/10, you get 1.35. And that would be your fourth term. Sorry, that looks kind of sloppy. And then to find your fifth term, you'd multiply by negative 3/10 again, and that would give you your fifth term, which would be 0.405. And that would be a negative 0.405. So what is your fifth term? That's negative 0.405. That's it. All right, solve. You may use a calculator and round your answer to the nearest tenth of a unit if necessary. So a ball is dropped from a height of 900 centimeters. The table shows the height of each bounce. The heights form a geometric sequence. How high does the ball bounce on the fifth bounce? So in order to find how high the ball bounces on the fifth bounce, we need to identify what the common ratio is of this particular sequence. If the table messes you up, then just write it out horizontally. So we have 800, 560, that's our second term. And then our third term would be 392. So to find our common ratio, we would just take this number here and divide it by 800. And if you do that, you get 7/10. So your common ratio is going to be 7/10. Now, we're asking for the fifth bounce. We're not going to use the explicit equation yet. We're just going to do this with repeated multiplication once again. So if we take 392 and multiply it by 7/10, that would give us our fourth term, which would be 274.4. And if we multiply that by 7/10, we'd get our fifth term, which is 192.08. So how high does the ball bounce on the fifth bounce? It bounces approximately, so on the right, fifth bounce, 192 1/800th of a centimeter. And that's how high it would bounce after the fifth bounce. Now we're getting to actually writing out the explicit rule. Okay, so remember, in order to write out, and let me write this up here, in order to write the explicit equation of a geometric sequence, you need to remember the formula. This is big for tomorrow's test. Make sure you know this. It's f of n equals f of 1 times your common ratio raised to the n minus 1 power, where f of 1 is your first term, and r is your common ratio. Make sure you have this memorized for tomorrow's test. Okay, so if we look at this table, in order to write an explicit rule, which is what they're telling us to do, we first need to figure out what our first term is, which our first term is going to be 5. And we need to figure out what our common ratio is, which it looks like if we take 20 and we divide it by 5, common ratio is going to be 4. We're multiplying by 4 every time. We have enough information to write our explicit rule for this geometric sequence. Remember, that's going to be f of n equals f of 1, which is your first term, times your common ratio raised to the n minus 1 power. So if we just substitute all the stuff that we have here into our formula, we have f of n equals your first term, which is 5, times your common ratio, which is 4, and that's raised to the n minus 1 power. Same with number 6. I'm sorry, not number 6, number 10. So if we look like at number 10 and we did take negative 3 and divide it by 6, we'd figure out our common ratio, which our common ratio would be negative 1/2, or negative 0.5. All right, our first term, f of 1, is going to be 6. So we just take that and we plug it into the formula. That would be f of n equals f of 1, which is 6, times your common ratio, which is negative 1/2, raised to the n minus 1 power. And that's it. Now we are given a geometric sequence, and we want to write a rule and then use the rule to find the 7th term. And again, you'll be using your calculators for these type of problems. So first step, though, is to write a rule. And if we take a look at this sequence, we have f of 1. F of 1 is going to be 5. Let me zoom in a little. We know our common ratio by taking 15 or 45 or 135 and dividing it by the previous term. 15 divided by 5 is 3. 45 divided by 15 is 3. Either way, you get 3. It means we're multiplying by 3 every time. So now we'll use that information to write an explicit rule. So that's going to be f of n equals your first term, which is 5, times your common ratio, 3, raised to the n minus 1 power. So now we're going to use this to find the 7th term. So if we plug in f of 7, that would be 5 times 3 raised to the 7 minus 1 power. Well, 7 minus 1 is 6, so this would be f of 7 equals 5 times 3 to the 6th power. And if you put this in your calculator, you should get 3,645. That would be your 7th term of this geometric sequence. Next, we have this geometric sequence, and I hope you could already start to see that your common ratio is going to be a fraction, right? Or decimal, because we're going down. But before we get to the common ratio, let's go ahead and figure out what f of 1 is. F of 1 is going to be, well, your first term, which is 972. And if you take 324 and divide it by 972, you get your common ratio, which is 1/3. So your general explicit rule is going to be f of n equals your first term, which is 972, times your common ratio, which is 1/3, raised to the n minus 1 power. Now, n in this case is 7, so it's going to be f of 7 equals 972 times 1/3 raised to the 7 minus 1 power. 7 minus 1 is 6. So 1/3 of 972 times 1/3 raised to the 6th power. And if you put this in your calculator, you would get, looks like you get 1 1/3, or 4/3 if you change it to a fraction. If not, it would be 1.3 repeating. And the last one's a word problem. Leo's bank balances at the end of months 1, 2, and 3 are 1,500, 1,530, 1,560 and 60 cents, respectively. The balances form a geometric sequence. What will Leo's balance be after 9 months? Write an explicit rule to find your answer. So we need to write an explicit rule. So we have our first term, which is 1,500. Our next term is 1,530. And our next term is 1,560.60. So we already have our first term, which is one key component that we would need to write an explicit rule. To figure out what the common ratio is, you would just take 1,530 and divide it by 1,500. And if you do that, 1,530 divided by 1,500, you get 1.02, which if you change that to a fraction would be 51 over 50. In this case, I'm just going to leave it as 1.02. It could be easier to just leave it as a decimal in this case. Okay, so 1.02 would be your common ratio, and your first term is 1,500. Now we use this information to write a general explicit rule. So f of n is going to be equal to f of 1, which is 1,500, times your common ratio, which is 1.02, raised to the n minus 1 power. Now, I'm asking you to figure out what his balance is going to be after 9 months. So that's what we're plugging in for, and f of 9 equals 1,500 times 1.02 raised to the 9 minus 1 power. Okay? And if you do that, that would be 1,500 times 1.02 raised to the 8th power. And if you put that in your calculator, you'd get your answer, which would be, and because we are dealing with money, we're going to round this to the hundredths place, so that would be $1,757.49 would be his balance after 9 months. That's it. That's all you'd have to do. Geometric sequences. This is the end of the study guide. Hopefully this helped. Hopefully you already had all these answers correct before you even watched the study guide. Now you're ready for your tests. See you tomorrow. Have a great day.